7-1. So first of all, just a reminder about some radicals and stuff. Root 36 is 6, and that's because 6 squared equals 36, right, everyone? So technically, yes, negative 6 squared equals positive 36 as well. So that's why sometimes when we say the square root of 36, we would say plus and minus. Now everybody listen though. If I said to you, simplify, find root 36, you just put the primary root, which is the positive root. We don't put plus and minus unless we're solving an equation, or I say to you, find all the roots. So we're just going to be doing the primary root. Okay, so if I said to you, evaluate. If you have fractions, the rule is split them up every time. That's always the rule. So square root of 1 on top is 1. Square root of 9 is 3. So we just go with the primary root, 1/3. Okay, can anyone tell me what this one is very quickly? 2.3, how'd you get that? Yep, root cancels out with power. Good. Okay, so evaluate. What's the square root of 81? There's a point to this. What's the square root of 90? You're not allowed to, let's say you're not going to have a square root button on your calculator. 30. Now how'd you do that? You said, let's just pretend it's square root of 9, which is 3, and then you add a 0, everyone. You guys know that. Okay, so we would split it up, square root of 1 over square root of 4, which would be 1/2. True? Square root of 0.16, so just pretend it's 16. It would be 4, so it's 0.4, everyone. Okay, now right here, what's this one? 13, you're doing good. Okay, now if I said to you evaluate, you got to pay attention to just little things. Like we have a negative 4 times root 36. That's negative 4 times 6, which is negative 24. We're good with the basics. This is root 9 is 3, plus root 16 is 4. So we would get 7. That is not the same as this. So this and this are not the same. Right here we have root 25, which is 5. So having them split up and together is not the same. We get the picture. Let's move on. Okay, the word rational, irrational, and imaginary. So rational means it can be written as a fraction. The root, the solution, not the solution, the root can be written as a fraction. So square root of 9 is 3. This is a rational root, meaning it can be written as a fraction, because 3 is technically 3 over 1. Does everybody agree? So we get rational roots when we have what's called a perfect square under the radical, meaning we square root it and it comes out to be a perfect answer. So irrational is when you cannot break down the root. You have something left under your radical. This is a decimal. It's a number that cannot be written as a fraction. So underneath, if it's not a perfect square, meaning we can't find the square root, then it's irrational. And then if we have a negative underneath a radical, it's imaginary, so it's not real. And in this unit, we're only dealing with real roots. So if you have a negative, we would just say this is not a real root. Because it's imaginary, right? We pull out an I, there's a negative under a square root. Okay, so just answer this one quickly. Determine if the root is rational, irrational, or imaginary, or not real. Imaginary, not real, same thing. Root 51. What is it? Irrational. I for irrational. Is everybody good with that? Why? Because root 51 does not break down. What's this one? Rational, because root 169 is 13. Does everybody see? Okay, right here we get not real. That'd be I, 9I. So this one is rational, isn't it? This one is irrational. We can't pull out everything. Right here would be not real. Right here would be rational, because this negative is just in front, which is fine. Okay, awesome. Now we're starting 7-1. So now that's going to help us lead into 7-1. So here's the first thing we have to realize. Even roots versus odd roots. There are some key differences when simplifying even roots and odd roots. So even roots will only have positive answers or i's. We're not going to do i's. We're only dealing with real roots in this unit. So square root of 4 is 2, and that's because 2 squared equals 4. We go with the primary root. Everybody good at that? So could I have, so we have the square root of negative 4. People will call that negative 2. That's not true. It's I to I, technically, right? Everyone? So we're not dealing with imaginaries, like I said. So our answers for evens will only be positive or not possible. So then odd roots, though, that doesn't happen. So cube root of 8 is, what is 2? Okay, good, and that's because what times what equals 8? 2. Well, can we have a negative under an odd root? Yes. Why? Because Isn't negative 2 cubed negative 8? Negative 2 times negative 2 times negative 2. That's 4 times negative 2. Isn't that negative 8? So it is okay to have a negative under an odd root. Our answer would just be negative, everybody. So evens will only have positive answers. Odds will have positive or negative answers. If it's positive underneath, positive answer. Negative underneath, negative answer. Good? Okay, let's answer these ones. Evaluate. You shouldn't really need to be taking notes during this time, honestly. The cube, so watching you're probably going to get more, because you're going to be able to work on the homework in a second. This is really basic. Cube root of 64. What times what equals 64? Yes. Positive 4. Okay, the 4th root of 16. 2. All right, the 4th root of negative 81. Not possible. We cannot have an I, people. Okay, cube root of 125. 4th root of 81. Cube root of a negative 216. Negative 6. Awesome. Okay, the square root of negative 32. Not possible. And then what would we do here? Yep, 5th root of 1 over the 5th root of 32. So 5th root of 1 is 1. 5th root of 32 is 2. 1/2. 5th root of 32 is 2. So now moving on to the next rule here. So when we're simplifying, would we need to put absolute values in our answer? So here is the rule, which we did learn this in Sec 2, so just a reminder. So the rule is, if we have an even root, we're only going to get positive answers. There is no possible way to get a negative answer when dealing with an even root. It's either going to be positive or I. So we have to make sure that we state that our answer is positive if this happens. If we have an even root and our answer comes out to have an odd exponent, then we need to add absolute values on our answer to say it's the positive this. Now, even root, odd exponent, that is the only time you need it. Even root, odd exponent, in that exact order. So now look why this is. So everybody look. So we look at here, we say root cancels out with power, we get x. That is true, correct? Yes, that is true. Now let's do that same thing here. Root cancels out with power, we get negative 2. Well, that can't happen. You just said that a square root had a negative answer. It's either I or positive. Do you guys see why that's a problem? So we would say, look, even root, did this come out to have an odd exponent? Isn't 1 odd? So we need absolute values. So the answer is actually 2. Do you guys see? Now think about why that is. We actually had negative 2 squared, which is negative 2 times negative 2. Doesn't that make our negative go away? So we actually were doing the square root of 4, which is 2. Do you guys see the problem? So let's see. Do we need absolute values on this one? Even root. There's not a 1th root, guys. If there's nothing here, it's a 2. We all know that, right? Even root, you get an odd exponent. 1 is odd. Do we all know that 1 is an odd number? So do we need absolute values? Yes. Okay, let's do some more. So just watching. Okay, it says simplify if possible and put absolute values when necessary. Doesn't root cancel out power? So x. Even root? No, so we don't need absolute values. X is fine. Root cancels out with power, so don't we get x minus 7 to the first? Even root? Odd exponent. We need absolute values, so absolute value of x minus 7. That's our answer. Okay, right here we have a negative 1 in front. Ignore that for a second. Root cancels out with power. We get negative 3. Even root? Odd exponent. So we need absolute values. So that's actually 3. Now we have 3 times negative 1, which is negative 3. What? Well, absolute value means positive, right? So we made negative 3, positive 3. Okay, let's do this one. Root cancels out with power, we get 5. Now let's check. Even root, odd exponent, yes. But isn't 5 already positive? So we don't need to put it on this. This is 5. Up here we had to put it because it was negative, and that was a problem. Do you guys see it? Okay, now variables, you always need it because it's an unknown. So root cancels out with power, we get z to the first. It's a variable, so even root, yes, odd exponent, yes, so we need absolute values. Root cancels out with power, 3x minus 2 to the first. Do we need absolute values? Even root? No. Odd roots can have negative answers. Okay, we're doing good. So now, one other thing to remember, radicals and fractional exponents are equal. They mean the same thing. So, if we have a base raised to a fractional exponent, that's called a rational exponent. Rational means fractions. So if we have a base raised to a fractional exponent, it is equivalent to having a radical. So that's equal to, so base A raised to the m divided by n is equivalent to the nth root of a to the m power. So we can switch back and forth. Not one is better than the other. It depends on what we're doing with the problem of why we would want to be in this form or this form. And you'll see some examples. So look right here. We have x to the 2/3. That is equivalent to the cube root of x to the second power. Now, a lot of people will get here and they'll say, I can't remember which one is the root and which one's the power. So then remember last year my cute little picture of my flower to help you remember. Roots on a flower grow on bottom. The power comes from the top. Look, roots grow on bottom. Power is on top. Are we good with that? Now, one other thing to note, you might see it written like this, or you might see it written like this, the cube root of x squared. This is still the same thing as this. You can have the 2 in here or on the entire outside. They are equivalent. You can see it either way. You guys see how they're the same? This and this are the same. Okay. Okay, here we go. So it says, write as a radical and simplify if possible. So this is one of the times that it would be better to have a radical than rational exponent. Because let's say I didn't let you have a calculator. You would have to be able to know how to do it by hand. So some people would say, 9 to the 1/2 power, I don't know how to do that. Instead, you should say, oh, 9 to the 1/2 power is actually the square root of 9 to the first, isn't it? Roots go on bottom. Square root of 9 to the first. So that is 3. You guys see how that's helpful? Now right here, isn't this the cube root? The cube root of negative 64 to the first power. What's the cube root of negative 64? Negative 4, everybody, right? Odd roots can have negatives. Are we focusing? Okay, right here we have the square root of negative 100 to the first power. Can we do that? No. Negative under an even root. So no, there's not a real root here. This is the square root of z to the first power. Right here we have the square root of 25 to the first, which is 5. Right here we have the fourth root of x minus 3 to the third power. Is there 4 we can pull out? No, there's only 3 of them. So that's our final answer. Yeah. So we have the square root of z, but it didn't simplify, so it wasn't outside. We had an even root, but we weren't able to simplify it. Does that make sense? Good question. Okay, all right, so we're going to switch now the other way. There's times when in a problem it would be better to go from radical back to rational exponents, and that's when we start doing properties of exponents. If you see a radical like this, square root of x times the cube root of x squared, to put these together, they have the same base. You would write it with rational exponents and use properties of exponents. So this would be this. This would be better if we were trying to put this together. Okay, so right here, rewrite this as a fractional exponent. So you'd put your base, x, you'd put your fraction, roots go on bottom. Isn't this a square root? And then power goes on top. So this one, now watch, because parentheses mean a lot, and a lot of people had a hard time with this last year. You have both 2 and x raised to the third, true? So we need parentheses, 2 and x are both raised to the third power. Power goes on top. Aren't they both under the same square root? So like that. Now there's a difference between that and this. Is 2 raised to the third power? No, so it's actually 2 to the first. So these are raised to their own power. So we have a 2 to the first, x to the third. The 3 can't be out here, or you're saying it's 2 to the third. Do you guys understand that? Now aren't they both under the same square root? Now go over here and draw your fraction. Roots go on bottom, so I got to put the 2 down here. Now, what power on top would not change these? 1. So our final answer here would be 2x to the third raised to the 1/2. Look at the answers. The parentheses are different. Yes? This has a 1. No, I was showing my work so that people knew what I was doing. Yeah, so maybe these, right here. Okay, so let's see. How would I write this one? 8b, then what? So we need parentheses, right? You said they're both under a fifth root and they're both raised to the first power. Okay, good. What about this one? That one's too easy. Roots going bottom, people. Flower. Okay, let's look at this one. Are they all raised to the fifth? Nope. Just the n. So they all have their own powers. So we have an n to the fifth over 3, right? They're not, the 5's not out here. And then they're both all under the 8th root. Then what do I put on top? 1. Okay, are all of this under a fifth root? And are all of this raised to the 4th power? Yes. So this one would be 10a squared b. They were all raised to the 4th power and all under a fifth root. Okay, awesome. So it says simplify if possible. So everybody, no calculators allowed. So you'd say, okay, this as a radical is going to be better. So this is the square root of 25 cubed, isn't it? Which is the square root of 25. Let's say you're not allowed a calculator, times 25 times 25. Now use your knowledge to pull out how we simplify radicals. Don't we pull out groups of 2? So there's 2 25, so we'll pull out 1 25 for the 2 25s. So we'll pull out a 25. Now, 25 breaks down into 5 times 5, doesn't it? So now we pull out a 5. Didn't we pull out everything? Now guys, there's multiplication in here, no addition signs. So there's no addition signs in these type of problems. It's multiplication. So 25 times 5 is 125. That would be my final answer. So right here we would say the cube root of 64 squared, which is the cube root of 64 times 64. I can't pull anything out, so start breaking it down. 8 times 8, 8 times 8. Don't keep going. Pull out what you can when you can. So I pull out an 8, don't I? And I pull out, what's the cube root of 8? We're really just doing this in sections, guys. What's the cube root of 8? 2. So I pull out a 2 as well. Can we do that in our head? Okay, so times by 2, we pulled out everything, so 16 would be our answer for this one. Okay, let's make sure we're good. Yes? Nope.
The first one, isn't it supposed to be less because you're like trying, like the numbers should be less than 25? Or like 75 because of the
Well, isn't that a huge number? 25 times 25 times 25 is a huge number, so it is smaller. Valid? No, it's a valid question. Okay, so let's do this one. We have the square root of -9 to the 5th power. Is that going to be okay? No, because it's going to stay negative. Why? Because the 5 is going to keep it negative. Does everybody see? So this can't happen. What if that would have been to the 4th, though?
Yes.
It would have been fine, because that would, something raised to an even power would cancel out a negative. So right here we would have the cube root of -8 to the 4th power. Careful, because a lot of people get tricked by this one. They'll say the answer is negative, but that's not true. The cube root of -8 times -8 times -8 times by, that's a times sign, -8. How many negatives? 4. Don't they cancel out? So then we're really just doing the cube root of 8 times 8 times 8 times 8. So pull out an 8. And then the cube root of 8 is, so 16 is our final answer. Okay, so last thing here, then you're going to work on 7-1. Negative exponents. This is really the last thing. If we have a negative exponent, it is not considered appropriate. You can't simplify something. There's no such thing as a negative root. So we have to fix it. So remember, this is how we fix negative exponents. Take the base, flip it down. So on bottom of our fraction, we would have x to the positive n, and then on top we have to have a 1. It doesn't just disappear. The top is still there. Now looking at this one, 1 over x to the negative n. We would take our base and flip it over a fraction. So now we have x to the positive n on top. On bottom we have a 1. In this instance, dividing by 1 is just itself. So this one we wouldn't need to write divided by 1. Right here we would need it though. So just quickly tell me how to rewrite these with positive exponents. This is what? 1 over x squared. This one is? X squared. This one is? Yep, 1 over x to the 3/4. This one is? 1 over 8 to the 1/2. We're getting the picture here. And then this one would be 25 to the 1/2. Okay, we get it. So it says simplify only if possible. So we would say, don't say it's not possible because that's not true. We would first say negative exponents need to be flipped. So that takes that down. 1 over 36 to the 1/2 power, which is 1 over the square root of 36, which is 1 over 6. Are you guys okay?
Yeah.
Okay, with this one, it's actually 27 to the 2/3. So then you could simplify it. The cube root of 27 times 27. There's nothing we can pull out that's the group's of 3 right now. So 9 and 3, 9 and 3, 3 and 3, 3 and 3. So we'll pull out a 3 and we'll pull out a 3, which is 9. Okay, right here we would say this is 1 over 6a. 6a to the positive 5/4. And now we can write it as a radical. So we have 1 over the 4th root of 6a times 6a. Can I just go for it? Times 6a times 6a. How many is that? 1, 2, 3, 4 times. Don't we need another one? Okay, now how big of groups are we pulling out? So there's 1, 2, 3, 4. There's a 6 we can pull out. 1, 2, 3, 4. We can pull out an a. So left under our 4th root was a 6a, and then on top we have a 1, and we're done. Okay, that's it. So go to 7-1, practice a few before we go on to 7-2. 1 and 2. So here's our properties of exponents. When we have the same base, so it's just a way to simplify something. If you have a base raised to the 0 power, it becomes 1. 1 is more simplified. Don't be the person that does this. Any base to the 0 power is 1, so they say it's like that. No, the exponent doesn't become a 1, the whole thing becomes 1. Do you see the difference? Okay, now right here, when you multiply the same base, we can put it into one base, which is better. When you multiply, you add. Remember the little song I sang last year? When you multiply, you add, okay? So when you multiply the same base, you can put it as one base and add your exponents. When you divide the same base, you subtract, everybody. So we can put it as one base and subtract. Here's the rule, always subtract the top from bottom, always. And then because we're taking the top from bottom, we're starting with our base on top. So it's going to be like that. A, we bring it on top, R minus S, and then we have a 1 on bottom. Do you guys see? When you divide, then you subtract. So far, when you multiply, you add. When you divide, then you subtract. Now right here we have a base, a power raised to a power. When we have a power raised to a power, we multiply the powers. So there's only one base here. It's raised to a power, we multiply. So everybody, the song goes like this. When you multiply, you add. When you divide, then you subtract. Raise a power to a power and you multiply the powers. Okay. Then the distributive property is just meaning if you have two different bases in here and there's a multiplication sign, you got to take R to both of those. Look, R. You see? Then right here, if it's division, all that stuff is raised to the R. You've got to make sure to raise everything to the R power. Okay, let's start practicing. Some of these are so basic you shouldn't need to take notes, like this one starting out. When you multiply the same base, so we have x to the 2 plus 3, which is x to the 5th. Everybody good? Okay, now over here people double dip. They say 2 times 2 is 4. And then you add those, so that's 5. You just double dip. You don't change the base. When you have a same base, when you multiply, you add, the base stays the same. So this is 2 raised to the 5th, everybody. Do you guys see? You do not change the base. Okay, now look, there is a difference between this and this. They're not the same. So right here, when you multiply, you add. You can't put these together. This is x to the 5th. However, When you see this, this is an addition sign. It's not being multiplied. So I had people last hour saying, okay, so this is x to the 5th too. Can you even combine those? No, they're not like terms. These are not, this is an apple, this is an orange. They can't be combined. Addition, you can't combine them. Multiplication, you can. Okay, so let's simplify this one. Is it the same base? When you multiply you, so we would say 27 raised to the 1/2 plus 5 6. Then by hand, we're going to get a common denominator. So times by 3 over 3. So that would be 8. 8 over 6. Does everybody see why? So then we have 27 to the 4/3. 8 divided by 6 is 4/3. So now from there, we can, because it's a whole number, we can actually now simplify it. So now we would say it's the cube root of 27 to the 4th power, which is the cube root of 27 times 27 times 27 times 27. Pull out groups of, pull out a 27, and then what's the cube root of 27? So 27 times 3 would be our answer. Are we good? Hey, when you divide, then you subtract, and you always subtract the top from the bottom. So guys, we're going to go like this. Let's put these together. We got to subtract the top from the bottom. So that's going to be 1/3 minus 5/3. Now it's gone. So on bottom we have a 1. So we have x to the 1 minus 5. Negative 4/3. Now there's your answer. What do you need to do? One last step. Flip it. Negative exponents are not an acceptable final answer. So we have 1 over x to the positive 4/3. Now here's how you know if you should stop. Should I write it as a radical or fractional exponents? Look back at the original. Did the original have fractional exponents or radicals? Fractional exponents. So our final answer should have exponents, not radicals. So we're done. Do you get what I'm saying? Couldn't we rewrite this as a radical if we really so desired? Don't do it because it wasn't it is a radical, but they're writing the answer as fractional exponents. So leave it. We're done. Okay, let's do this one. When you divide, then you don't divide out the 8s. It's 8 to the 1/3 minus 5/3, which is 8 to the negative 4/3, which is 1 over 8 to the 4/3, and so on. Okay, watching. Raise a power to a power and you multiply. So this is x to the 6th. Now right here, base 36, raise a power to a power. So don't we multiply? So you multiply, yep, straight across. So you multiply straight across, you get 10 on top. Straight across, you get 20 on bottom. So now we have 36 raised to the 1/2, which is the square root of 36, which is 6. Okay, good. Now note, these are not the same rule. This is the rule that gets mixed up one of the most times. This rule versus this rule. When people learn this rule, then they go back to this and go, when you multiply, you multiply. No, when you multiply, you add. This one's x to the 5th. This one is raise a power to a power. Do you see the difference? 6. Okay. Okay, here we go. Simplify. Now everyone pay attention. Multiplication. This is a multiplication sign, so it would be okay to take 3 and distribute there and there. So that's x cubed, y to the 6. You multiplied. Okay, good? Right here, it's a multiplication sign, so it would be okay to distribute there and there. Watching carefully, we have x. Multiply straight across. 1 times 3. 2 times 2. Okay, moving on to y. 2 times 3 is 6. 3 times 2 is 6. So that become a 1. Are we good with that one? Okay. This is really important to figure out, to realize here. There's a difference between this and this problem, a huge difference. This would not be okay to take the 3 and raise it to the 3rd power and 3rd power. This is not okay to have x cubed plus y to the 6th. This is not a properties of exponent problem. That is breaking the most forbidden rule of all forbidden rules of math. You can't do it. Does everybody see? But this has a multiplication sign, so it would be appropriate to distribute.
Wait, why?
The addition sign. So what this actually means is x plus y squared times x plus y squared times x plus y squared. Now I promise if you were to distribute that out, it will not come out to be x cubed plus y to the 6th. Does that make sense?
Yes.
Okay, yes.
So I just figured if something like that, we don't have to know that, or
Yep, we would have to do all that. Okay, so here we go. Simplify. I won't go through it if you can tell me what to do. When you multiply, you add. I would say the same. When you divide, then you. Then right here we have a power to a multiply, and here we would distribute and multiply, right? Okay, focusing, focusing, focusing. It says simplify. Now guess what people think? And I guarantee there's people out there right now that think this. I need to distribute. What the heck? No, this is one term. There's a multiplication sign, a multiplication sign, a multiplication sign. Do you guys see? This is not a distribution problem. This is one term. So the parentheses are there. They're telling you to do something. So let's look here. We have this, and they're in parentheses. It's not telling us to do anything, correct?
Yeah.
So that's just x to the 2/3 times y to the -1. Moving on. We have parentheses raised to the 2/3. So it's telling us to take our 2/3 in. Still a times sign, so we have times x to the -2/3. And then we have times by y to the 2/6, which is 1/3. Now look, it's just a multiplication problem, not a distribution problem. So reorder it. Put like bases by each other. X to the 2/3 times x to the -2/3 times y to the -1 times y to the 1/3. So doesn't this become, when you multiply, you add x to the 0. You're right, we've got 2/3 plus -2/3, 0. Now put these together. When you multiply, you add. So when we have -1 plus 1/3, so we would need a common denominator. So multiply by 3/3. So now what do we have? -2/3. Would we? So right now we have this. X to the 0, y to the -2/3. Now we need to simplify that because that's not appropriate. X to the 0 is? Gone. Good. 1. And then we flip that bad boy. Our final answer would be 1/y to the 2/3. Don't write it as a radical. Why not? Because look, the original had fractional exponents. So leave it. So with this one, there was a multiplication sign, so we could reorder things. Right here, this is an addition sign. We could take 2/3 and put it in, because that's a multiplication sign, but then we would not be able to put them together somehow, unless they're like things. Yeah. So you leave them separate. Yeah. Yep. Okay, so it says simplify. Everybody listen, when you have something big and nasty, you need to simplify the inside first. So let's focus on making the inside, ignore this for a minute, making the inside bit better. So 9 doesn't divide with anything, so we still have a 9 on top. We're dividing the same base, so we subtract, right? So we would have x to the 1 minus 5, 6, right? Okay, and I'll come back and do that in a second. And then like here, when you divide, then you, so we have a y, and then we have a 4/3 minus -2/3. So on the bottom we have a 1. So let's simplify this. So we have on top a 9. We have an x to the, you said you got we need a common denominator, times by 6/6. So that's 6 minus 5, which is 1. So 1/6. Is everybody good? So x to the 1/6, and that's on top. And then 4/3 minus -2/3. So that becomes plus plus. 4 plus 2 is 6/3, which is 2. So we have a y squared, and then 1's on bottom, isn't it? And then that was all, because we simplified the inside. There's only one x, only one y, one number. We now have 1/2 out here. So now we would take and 1/2, 1/2, 1/2. So we have 9 to the 1/2. We have x to the 1/12. We have y to the 1. So do any of those things simplify more? Yeah, square root of 9 is, so our final answer is 3x to the 1/12, y to the 1st.
Are we supposed to do it to the 1 on the denominator?
So yeah, and then 1 to the 1/2 power, the square root of 1 is 1, and then divided by 1 is just itself. So we just said anything divided by 1 is just itself, so we didn't need to worry about it. Good question though. 'Cause yeah, technically we did. Okay, so it says simplify. So we would take, and guess what people do? They times 8 by 2/3. No, it's 8 raised to the 2/3, everybody. Then we have x to the, raise the power to a power, and you multiply. So it looks like I'm going to have a 6/12. Then I'm going to have a y to the -2/3. So start simplifying. This is the cube root of 8 squared. That's the cube root of 64, which is 4, everybody. Now we have an x to the 1/2, don't we? And then what should we do with our negative exponent? Flip it. So we'll have y to the positive 2/3 on bottom.
Wait, why do you
Because 6 divided by 12 is 1 divided by 2.
Oh, I don't see the one in front of the 12. I know it's the 6 divided by 2.
Gotcha. I see what you're saying. Are we good? Okay, so you don't need another one of that caliber, right? Okay, moving on then. So with this one, be careful because this is just what I see people do. They take 8 and they multiply that in first. No. All of this stuff is raised to the 2/3. So you have to take care of that first, and then you can multiply 8 to that, whatever that is. Do you need me to continue, or do you get what I'm saying? Yeah, exponents would have to come first. It's parentheses for a reason. Okay, it says simplify. So you'd say, okay, so there's a couple ways to think of this. First of all, this is the 8th root of 16 times 16 times 16 times 16, true?
Yeah.
Which is 4 times 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 4. How many 4s is there? So what my answer is? 4, because there's 8 of them. Okay, let's do this one. 64 is 8 times 8. 4 times 2. 4 times 2. 2 times 2. 2 times 2. Don't double dip. 4 is written as 2 and 2, so it's not there anymore. It's not there anymore. 8's not there. 8's not there. 64 is not there, in fact. You've rewritten it as this. Pulling out groups of 3. So we'll pull out a 2. We'll pull out a 2. 2 times 2 is 4. Now, how many groups of 3 are there in 6? 2. So you did 6 divided by 3, which came out perfectly, which was x squared. It was 2. 3 divided by 3. 1. There's one group of 3, so y to the 1. Was there anything left underneath? Nope, so we're done. Now let's check. Even root? Nope, so we don't need absolute values. Okay, I'm just showing you this one needs absolute values. What's the 4th root of 16? 2. If you didn't know, you'd break it down by hand, right? Then 8 divided by 4. So it's squared, right, guys? There's 2 groups of 4. Then how many groups of 4 are there in 12? 3. So 12 divided by 4 is 3. So we have b to the 3rd, and we pulled out everything. Even root, odd exponent, yes, but 2 is already positive. Moving on, odd exponent, no, odd exponent. So you would need absolute values only around that. Okay, it says simplify. Now here's the thing. A lot of people go about this 100% the wrong way. They say, I'm going to rationalize my denominator. You're making it a nightmare of a mess. We don't need to do that. Don't we have the same base? Yeah. Well then, those are just the properties of exponents. We have an x to the fractional exponent of 2/3 on top, and on bottom we have x to the 1/4, don't we? Yeah. When you divide, you subtract, so we're really dealing with x to the 2/3 minus 1/4. And then you get a common denominator. So times by 4 over 4, times by 3 over 3. So now we would have 8 over 12 minus 3 over 12, which is 5 over 12. So my answer is x raised to the 5 over 12. So much easier. Now look, did we start with radicals? Yeah. Then our final answer needs to actually be written as a radical. So now we'll take that and say, so that's the 12th root of x to the 5th power. Okay, another one. So you'd say, a lot of people would say this is hard, and then you would say, no, actually it's not. Those are just fractional exponents. So let's work from the inside out. Isn't this, let's rewrite this part. Isn't this a raised to the root goes on bottom, 3, power goes on top? I've taken care of that. Now all of that is under a 4th root. All of that is under a 4th root. Don't roots go on bottom? Then that must be a 1 to not change that. So now raise a power to a power and you multiply. 2 times 1 is 2. 3 times 4 is 12. So our answer is a to the 1/6, isn't it? We started with radicals, so our final answer will then be written as the 6th root of a to the 1st power. Okay, we're almost done here. Stick with me. I know it's been a long lesson. Stick with me for these last few. So everybody was having a really hard time yesterday with these problems. So I'm going to start out really basic to get you seeing what we're doing. If I said to you simplify, you'd say, okay, so I need to take this and multiply it in. 2x times 5x squared is 10x cubed, right, everyone? 2x times positive 3x is positive 6x squared. Now, guys, if the reason you were able to do that so easy is because you've seen it so many times that you're good at it. Now, what did we actually do here? Watch my work so you can see when I do harder problems. We actually did 2 times 5. So we did 2 times 5, didn't we? Then we had an x times by x squared. So now look, that's 10. And then when you multiply, you add. That's why we got 10x cubed. It's so intuitive because we've done it so many times. So you guys see. But we still did just add our exponents. So everybody look right here. People were freaking out yesterday over this problem. And it's understandable because it's hard for people. But aren't we just distributing just like we did here? So this times this. So you're going to have a 2 times a 5, which is a 10. Now we have x to the negative 1/2 times by x squared. When you multiply, so we have x to the negative 1/2 plus 2. So now let's keep going. Oh, we can simplify that. So we have 10x to the negative 1/2 plus 2 over 1. Get a common denominator. Times by 2 over 2. So that's negative 1/2 plus 4/2, which is positive 3/2. So we actually have 10x to the positive 3/2. Moving on. 2x to the negative 1/2 times that. So wouldn't that be plus 2 times 3? 6. Then we have an x to the negative 1/2 and 1. So what would we do? Multiply it? No. When you multiply, you add. So we're going to have x to the negative 1/2 plus 1, which is what? 1/2. Now, can I combine x to the 3/2 with a 1/2? No, because they're not like things. That's like combining x squared and x cubed. You can't do it. They're not the same. So we're done. What? So we added this up and got positive.
Yep. 6x, 1/2.
Yep, it's positive.
But it's 2x. Oh,
Yeah, because we did 1 plus negative 1/2. Okay, so are we good with that kind? You don't want another one like that? Okay, sweet. Okay, so with something like this, I won't go through it if you can tell me what you would do correctly. What do you mean distribute the negative? Where would you distribute it to? There's not multiple terms. Do you see? There's not multiple terms here. Yeah. So you're saying take this and simplify the inside. Okay, you're correct. We would simplify this one. Then we would take this. Would we distribute a half through first? No. Simplify first, then take a half in, correct? And then you would compare your two things and see if you can combine them. Maybe not. Maybe they're like terms, though. Maybe they're not. You leave them apart if they're not like terms. Yes?
Would you keep it first and then?
I don't. I just use properties of exponents. So I go, when you divide, you subtract. You subtract the top from the bottom. So that's negative 1 minus negative 1/2, isn't it? Oh, that's not a y. My bad. So it's actually negative 1 minus negative 2/3, right? Do you guys see what? I just do it like that. Because then there's unnecessary steps, I feel like, sometimes. Yeah. What do you think I should do here? Same base, same base. You can put them together with properties of exponents. So you would rewrite them as fractional exponents. So we have p to the 3/4 times p to the 1/3. When you multiply, you add. So let's get a quick common denominator. So that's 3/4 plus 1/3. So times by 3 over 3 times by 4 over 4. So that's 9/12 plus 4/12, which is 13/12. So our answer is p raised to the 13/12. Then did you start as a radical? Yes. So my final answer is the 12th root of p to the 13th power. Now don't start pulling stuff out. You're going to end up like don't keep going. Just stop there because we were putting it together. That was the goal. We could keep going on forever. Pull it out and then you could rewrite it. It could never end. Do you guys see what I'm saying? So just stop. Okay, awesome. Now this one, people feel like they can't put it together because they don't have the same base, but we actually kind of do. So isn't this 36? How could we write it as base 6? 6 squared. Everybody, do you agree? So this is the same thing as the square root of 6 over the 4th root of 6 squared, isn't it? So now write it as fractional exponents. So we have 6 to the 1/2 on top. On bottom we have 6 to the, roots go on bottom, power goes on top. So we have 6 to the 1/2 divided by 6 to the, which is 1/2, right? So then it would become 1. It would divide out and become a 1. Or exponent of 0. Okay, these are the last two. So this says, simplify by factoring out x to the 1/3. Simplify by factoring out x to the 1/3. It tells you what to do. So it's literally just testing, do you know how to do algebra with factoring? So guys, this is how it works. I need you all focusing because I know that people that are not watching right now are going to ask me. And I'm going to be annoyed because I actually answered it and you just weren't paying attention. So, it tells us to factor out x to the 1/3. That means pull it out. So we're going to pull out x to the 1/3. We've got to write it. We pulled it out. Now what we're going to do is we're going to go back and see this is a term, this is a term. We're going to see what's left over once we pulled out x to the 1/3. So in our parentheses, we're telling what's left over in the first term and the second term. Are you with me? So when we pulled it out, we actually technically divided it out. So now go in sections. 9, nothing divided out with the 9. 4/3 and x. X to the 4/3, x to the 1/3. What would you do? Subtract. When you divide, then you subtract. So this is 4/3 minus 1/3, which is 3/3, which is? So we have 9x to the 1. Moving on, we have a 4, and it's actually positive 4, so plus 4. And then x to the 1/3 divide out, and then left is 3x plus 5. Now look inside your parentheses. Combine like terms. So we have x to the 1/3, 9x. Then we have plus 12x's plus 20, don't we? So we actually have x to the 1/3 times 21x's plus 20. And now we're done. Last one. What? What do you mean factored out of the 'Don't understand the question.
You don't, inside the parentheses where it says 30 you don't have to factor out x.
There wasn't an x to the 1/3 there.
Yeah, you're just saying why not factor out.
3x plus 5 is connected, right? So you can't just divide a piece of a plus sign out. Okay. Okay, here we go. This is just a question real quick. Can I take 2? Can I take 2 and multiply it in? Look at the problem. Yes. People, we can. Look at the problem. What is telling us that we can't do it? Nothing. So that would be 2x minus 6x squared. Isn't that okay? Yes, that's fine. Okay, look right here. Could we take this one and multiply 2 in? No, because of the degree 4. And 2 is not raised to the 4th. Do you guys see the difference? Okay, now guess what a lot of people do? They see this and they say, oh, 2 in. No. There's an exponent. So we would, if we were going to do this one, we'd have to do 2, x minus 2 times x minus 2. Then we would multiply these two together, combine like terms, multiply these two together, combine like terms, and then multiply it together. Okay, cool. So it says, simplify by factoring out that. So let's do it. So watch, because as you can see, a lot of people get confused with these. So we're going to factor out. I pull it out, so I write it. 2 times x minus 4 to the negative 1/3. Now what's left in each term? We're going to go back and see. Here's a term, here's a term. So we pulled it out, so we divided it out. So we divided out 2x minus 4 to the negative a third. We divided out 2x minus 4 to the negative a third. And let's see what's left over in each term. 2's divide out. Aren't those the same thing? And they divide out. So left would be 4x minus 3. Are we good with that? Now we have plus 6. 12 and 2 are 6. And then careful, same base. When you divide, you subtract. So subtract the bottom, which is negative a third. When subtracting a negative, we make it plus, don't we? Which is 3/3, which is 1. So that just became x minus 4 to the 1. So now combine like terms on the inside. So we have a 2, we have an x minus 4 to the negative 1/3, and now inside. We have to distribute 6x minus 24, combine like terms, 4x plus 6x. 10x is negative 3 minus 24, minus 27. Now look at your final answer. Is it appropriate? There's one thing that's not. What? It's a negative exponent. So what do we need to do? Draw your line and flip the base. Should 2 come down? Nope, 2 is raised to the positive 1. That's fine. Only flip the part that has a negative exponent. So x minus 4 to the positive 1/3. So my final answer is on top 2, 10x minus 27, and on bottom x minus 4 to the 1/3. We got be really good at algebra. Be really good at algebra. That's why this is called pre-calculus. Calculus is what fails calculus. What fails people in calculus is algebra. So that's why we're getting really good at stuff like this. Okay, that's the end of the lesson. So 7-2. Notice 35 doesn't tell you what to factor out. I'm telling you what to factor out. 36 doesn't tell you, so make sure you write it down. The instructions got cut off.